On January 2, 2025, the Minor Planet Center, an organization operating under the official authority of the International Astronomical Union to catalog and monitor small bodies across the solar system, announced the identification of what initially appeared to be a newly discovered near-Earth asteroid. Astronomers routinely detect such objects, track their trajectories, and classify them so they can better understand potential risks or scientific opportunities. But in this particular case, something unusual happened almost immediately after the announcement. Within just a day, officials reviewing the observations noticed that this supposed asteroid displayed an orbit that mirrored, with remarkable precision, the known trajectory of the Tesla Roadster car launched into space by SpaceX in 2018 as a dummy payload aboard the Falcon Heavy rocket. The realization left no room for ambiguity. The object was not an asteroid composed of rock or metal, but rather the same Tesla sports car drifting silently through interplanetary space. Once this was confirmed, the Minor Planet Center promptly removed the entry from its asteroid catalog, acknowledging that the classification had been an understandable mistake produced by an automated detection system that had momentarily confused human-made debris with a natural celestial body. The incident, although amusing on the surface, illustrates a deeper point about our assumptions in astronomy, the limitations of our training data, and the potential for misclassification when our expectations shape what we believe we are seeing. Elon Musk, the individual responsible for launching the Tesla Roadster into space as part of a publicity-rich demonstration mission, is often praised as a visionary within the commercial space industry. However, in the grand cosmic context of the Milky Way galaxy, which spans more than 100,000 light-years and contains an estimated 100 billion stars similar to the Sun, Musk is almost certainly not the most advanced or accomplished spacefaring engineer to ever emerge in the history of the universe. If even a tenth of those Sun-like stars host Earth-sized planets located in the habitable zone, a reasonable estimate based on current exoplanet statistics, that means there may be billions of worlds with environments conducive to the evolution of complex life. Once you imagine billions of Earth-Sun analogs, each offering its own evolutionary path and technological potential, it becomes statistically compelling to conclude that some of those civilizations must have surpassed our current capabilities long ago. Most of the stars in the Milky Way are far older than the Sun, many by billions of years. And this enormous temporal head start provides hypothetical extraterrestrial civilizations with vast amounts of time to develop, advance, explore, and possibly spread technological artifacts throughout the galaxy. To appreciate the scale of these possibilities, consider that our own Voyager spacecraft, built with the modest technologies of the 1970s, will traverse the Milky Way's disk over the course of 1 billion years. Although Voyager travels slowly by cosmic standards, it nevertheless demonstrates an important principle. Even primitive probes, given enough time, can cross immense interstellar distances. If that is true for our rudimentary machines, then it follows that any civilizations older and more advanced than ours would have had countless opportunities to launch far more capable probes, instruments, or spacecraft that could drift or intentionally travel into our solar system. The solar system, therefore, should not be seen as isolated or protected from interstellar arrivals. On the contrary, it should be considered a plausible resting place, or even a destination, for artifacts originating from intelligent beings elsewhere in the galaxy. This raises an intriguing question, one that challenges traditional scientific assumptions. If an interstellar object entered our solar system and it happened to be a technological artifact rather than a natural comet or asteroid, would our astronomical community be able to recognize it as such? Most comet and asteroid experts have spent their entire careers studying icy rocks, dust-covered bodies, and gravitationally sculpted materials that formed billions of years ago. Their mental models, research frameworks, and academic training are built upon natural phenomena. As a result, when they observe an anomalous object behaving in ways that do not align with typical cometary activity or known asteroid behavior, their instinct is to reinterpret the anomaly within the constraints of natural explanations rather than entertain technological possibilities. This bias is not the result of carelessness, but of human conditioning and professional habit. Scientists work within paradigms, and paradigms define what seems plausible. When anomalies arise, the default response is to stretch existing theories to accommodate them rather than consider entirely new frameworks. I do not think experts would readily recognize an alien artifact, even if it were operating directly in front of them. Their intuition would drive them toward the familiar, and their observational tools would interpret data through software optimized for natural celestial bodies, not for artificial structures. The example of the Tesla Roadster being temporarily cataloged as an asteroid illustrates precisely how easily a human-made object can masquerade as a natural cosmic body when detected in space. A car floating through the void is obviously artificial once identified, yet until cross-referenced, it blended seamlessly into our automated reporting systems. If this level of misclassification can occur with an object we ourselves launched only a few years ago, imagine how much more challenging it would be to correctly identify an interstellar probe built by an unknown civilization using technologies far superior to our own. To broaden the perspective further, consider the case of 3I/Atlas, the third known interstellar object detected passing through our solar system after the discoveries of 1I/Oumuamua and 2I/Borisov. While the scientific community has attempted to interpret 3I/Atlas through the lens of standard cometary physics, there are at least a dozen anomalies associated with it that challenge conventional explanations. These anomalies are not minor details, but significant deviations from expected behavior, raising questions about composition, trajectory, light reflection, structural stability, and non-gravitational acceleration. Many of these properties do not fit neatly into existing astrophysical categories, yet the reflexive assumption has been that the object must be natural, because that is what decades of precedent have taught astronomers to expect. But such confidence may be misplaced, especially when data suggest that alternative interpretations, including technological origins, should not be dismissed out of hand. Scientific progress depends on the willingness to examine evidence objectively rather than selectively. The universe may contain phenomena that defy our established classifications, just as quantum mechanics once defied classical physics and forced humanity to rethink the nature of reality. If we only allow ourselves to see what we already believe to be possible, then we risk missing the profound and transformative discoveries waiting to be found. Interstellar objects offer one of the most promising avenues for expanding our understanding of life, intelligence, and technology beyond Earth. The fact that they wander into our solar system without requiring us to build interstellar spacecraft of our own should be viewed as an extraordinary opportunity. Each visiting object could contain clues about the chemical makeup of distant planetary systems, or, in rare cases, the technological fingerprints of civilizations far older than ours. The irony is that we may be surrounded by evidence, yet unable to recognize it due to preconceived notions. Just as early scientists once resisted the idea of meteorites falling from the sky because stones could not possibly come from space, modern scientists may be resisting the idea that interstellar visitors could be artificial because such a concept falls outside their comfort zone. But nature does not care about our comfort, and the universe is under no obligation to conform to our expectations. If we allow ourselves to consider all possibilities, including the ones that seem improbable, we open the door to genuine discovery.